Polynomials, right? Keep in mind this is going, we started at 3.1 with families of functions, right? That was the big picture of graphing equations and everything that comes along with it. One of those functions was polynomials. Well, actually several of them. Now we're going to take those several functions and go into detail about them. Okay? Welcome back. So, I'm going to go through, polynomials are of this form. Right here. You can see that. They're exponents. So you have y equals x squared, and y equals x cubed, and y equals x to the fourth, and y equals x to the fifth. Those are called polynomials. And every iteration thereof. Okay? Do you know what this function is called? The one up there right now. Y equals 3. Okay, you can see the equation. You can see the equation right here. It's a flat line, right? That's called a constant function. There's no variable, right? You've graphed horizontal lines. That's what that is. All right. We've just set boundaries on the x values here. No big deal. Okay, that's y equals 0, right? Okay, now what about a linear equation? That's y equals 2x plus 0, right? So what's the slope? The y-intercept? 0. Now I can change the y-intercept, right? 2x minus 3. Okay. That's a polynomial equation, right? Yes, because it has an exponent of x, right? What's the degree of this equation? 1. Degree 1, because that's the highest exponent, right? Okay, so degree is a big thing for today. Keep that in mind, because it is important. It tells us something about the equation, something that we're going to use a lot. So if I have what's the degree? Yes, right. Now, does it matter what order they're in? When you write it, I want it to be in order. Okay? So 3, 2, nothing. Sometimes you're presented with functions that are not written in order. Because what's the degree here? 4 is 4. Okay, good. So keep in mind that may not be in the first spot. When you write it, I want it to be. Okay, so write it in order when you write it down. Because of families of functions, if you see the degree out front, it can give you a general idea of the shape of the function. Okay, so that's degree. So linear functions of degree 1, right? What's a quadratic?
Degree 4.
Degree 2. Yeah, so let's just go with the parent function here. Oop. Okay, there's 1x, there's x squared, right? Parent function. Now what can we do with it? We can move it to the left or the right, and we can move it up or down, correct? Okay, what do you notice when I move it down? Minus 2.96. Notice this is not in parent function form, it's in standard form. This is the y-intercept, right? If I move it just a little bit more.
So what would you do to get that 7x?
This one,
Yeah.
you would, if it was in parent function form,
Sure.
or how would you get it to parent function form?
No, I forget how you get it.
It's called completing the square.
Fine.
We're going to touch that next week. Now, the important part of this is what's the y-intercept and what are the x-intercepts? -2 and 2, I've kind of set you up there, right? Okay. Those are also called zeros or roots, x-intercepts. Those three vocab words all basically mean the same thing. That is the main focus of our chapter, how to calculate those values. Okay? How many does a quadratic have?
4, 2.
This one has 2. Can it have 1?
Is it equivalent to its highest exponent?
That's a great question, Montaigne. How many does that have now? 1 or none. Okay, so you are onto something. It's called the fundamental theorem of algebra. The number of the degree of the equation is the maximum number of x-intercepts. So a cubic, how many can it have? 3. But it might have 2, and it might have 1, and it might have none. Real number x-intercepts. Okay. So what? That one? How many, what does it have there?
None.
None. How many does it have now?
Infinite.
Yep, infinite number.
Okay.
So, alright, so cubic, remember what that's shaped like? We can also do stuff like that to it. Okay. And then a quadratic, or quartic, the base of which looks like a quadratic, right? But then we can also add humps in it like you saw in your test. Okay, and we can also turn it upside down. And lots of things you can do with these. You're not going to have to graph a lot of these. Okay, so we're going to use our calculators a lot. And then you have a to the function to the 5th. Okay, same look as cubics, right? So kind of an overview, what do the graphs look like? What is degree? Any questions yet? Let me make sure I'm covered. Polynomials. Degree. that might become a part of this.
Oh, great.
What you need to know is when do these come into play. So if I have an equation, just sketch something up, a graph. This has two x-intercepts, right? Those are real numbers, correct? Okay. That's mostly where we're going to work. This is where calculus hangs out, in the real numbers. Okay. What else do you have to know, though? How many x-intercepts does that have?
None.
0 real number x-intercepts. 0 real. When you calculate this out, the roots or the x-intercepts are imaginary numbers. You remember what those are?
Yes.
Okay, so this would have two imaginary x roots. Okay. Or zeros, whatever you want to call them, right?
So would that be?
So if it's not touching the x-axis,
So when you do this, and it doesn't have zeros, do you just automatically take the degree and assume that it has that many imaginary?
yes, basically.
Well, that's one.
So know that these are different number systems. What does the real numbers include? We have integers,
Yeah, those are rational.
rational, irrational,
Everything's in there?
yeah, stuff that doesn't make sense, right? Irrational number. We have a whole, and we have natural.
Those are natural numbers.
Those are counting numbers.
Those are numbers
They're
that
the counting numbers, basically.
Oh, so one person.
Naturals are 1, 2, 3. The whole numbers are 0, 1, 2, 3. I'm not going to hold you to knowing those, but this is where we're going to work mostly. And then this, the imaginary or complex numbers are their own separate entity. Okay. They are very useful. They are not real numbers, but if you're going to be an engineer, you're going to work with this. Because I can show you electrical applications, heat transfer, all these different applications that actually use the complex numbers, and it works.
What about mechanical?
Very, very weird, but it does work. I don't think I can count a mechanical example off the top of my head, but I could try find it.
So, like, what's the app, what's like the
Well, mechanical, heat transfer, that's mechanical. Heating, ventilation, air conditioning, that's a mechanical application. There you go, Hunter.
So then what's, is there any other, I can think of any sort of application outside of like engineering of any sort?
Of this stuff,
Yeah.
that shit. You wanna be a rocket scientist?
No.
Be a rocket scientist.
Okay, well, this pertains to my day to day.
Engineer.
Like, so then,
Rocket
longevity.
I love these questions like once a month. Okay. Am I aware that most of you will never use this math?
Ever
This
again?
content again?
Yes.
You bet.
Not it.
Fine. That's great. Am I also aware, are you aware, that every single day you have to solve problems?
Yeah.
This is the best place to practice that. The math classroom.
Why can't you just teach us? to-
Yeah, roll your eyes. It's very true.
Lecture.
Okay. Problem solving. Mathematics classroom is the best way or place to learn that. Logical logical thought process, do you like to think logically, or do you like to be irrational? Yeah, I know you like to be irrational.
We're high schoolers.
But that does not work very well in the workplace. No, it doesn't. Trust me.
I'm
We've been dealing with it a lot.
You gotta be irrational sometimes.
Okay. So, is is 4 a 0 of x squared minus 16?
Yes.
How would I know that?
You plug it in.
Plug it in. And it equals?
Yeah.
There you go. That means it's an x-intercept on the graph.
So wait, but that
Okay,
means
so, yes, this function has two zeros, 4 and negative 4. I'm only asking you about one of them. Okay? So that would be yes because it gives you 0.
Mr. Arthur,
I,
would the 0 also prove that it's continuous?
this would only be step 1. This shows that there is a point. Y of 4 equals 0. If you want to show it's continuous, you also have to do the table with 4 as your x value,
3.9.
and this would have to be 0 for both sides.
See, that's why I thought you put it in zeros, because you got zero.
No.
It's
Yeah.
4 a 0 of that function.
Maybe. Yeah. No, I haven't.
No. 4 cubed minus 12 times 4 is 64, 48,
Ah.
not 0.
Ah, can't do
Okay.
that.
Well, there's one way, if you're asked about a root, to say yes or no right away. You don't have to graph it. That's algebraic or numeric method, okay? Now, what if I give you
I'm 2 for 2.
let me make sure this-
I'm so well. So I don't know anything from them.
Okay, so if I give you the roots, generate the polynomial.
Oh. I still can't do this.
This is not a big process.
Yes.
No, isn't that like I squared equals 1?
What if it was 2?
Remember, these have to give us
Negative.
0, correct? So what do you partner 2 with to give 0?
Negative 2.
Negative 2, so we have x minus 2.
Whoa, magic.
Times?
Oh, wait. 4 minus
And
negative 4 plus 4.
there's your polynomial.
Wait,
That's a
did it?
trinomial, right?
Yes, poly meaning many, right? So many x's. It is a trinomial, you are correct, because there are 3 of them. What's the degree of that polynomial? No.
0.
3. Because when you multiply this through, if you FOIL it out, you get x cubed. Correct?
And to turn that into an equation, would you just distribute and then distribute again?
Yes.
Oh, that's horrible.
Can you multiply this out? Great.
Yeah.
FOIL, remember out?
Yeah.
So I'm going to do these two first. First times first. Outers
Or I.
Yes, you
minus plus 4ix and minus 4ix, and then that is negative 1, correct? I squared is negative 1.
So negative 17.
I told you it was squared. I told you that you have to square. So why would you FOIL those?
We're going to do it. The reason I did these two first, notice they're the same numbers with just the plus minus difference. The middles always cancel. Right? So we're being strategic here.
You made this.
So I made it another FOIL problem.
When you squared it, you made it so the first section would equal 0.
Yes. So you create your polynomial because these have to make each one of these 0. And then FOIL this out, right? First, outer, inner. Done yet? We gotta write them in order. I want you to write it right. It's just cleaner. Yes, I know it's more work. It's just cleaner. Okay. Are we okay with that? Okay. Last one. Get a calculator.
Keep boiling it until do that.
I'm putting it in right here. You see that? Okay, put your equation in y. We need to be getting faster at this, right? We're just going to worry about the real number roots because that's all the calculator will give us. Okay, so there's your equation you need to put in. When you throw things on the ground in anger, they tend to break. Are we good? Can we move? Hey, fast that grasshopper.
It's cool looking, guys. It's like you.
Are we good?
I'm cool looking.
Now arrow to the right.
Yeah. I put 4. Now do I know what we need to do?
Arrow to the right. It should bounce you back down to the bottom.
It's on the same line. It's just
Oh, yeah, you're okay. She knows. It's just a different operating system. You have like one iteration older.
So now what?
So if you ask for the degree on this one, it would be
Form. If you do zoom standard, because it'll show the graph nice. Phenomenally. Okay.
Yeah, it's kind of like the
Okay, there's zoom standard, right? So what do we need to do? Okay, we can try it. Is it going to work? Okay, it's not going to work. So we need to expand our y values, right? The window, I'm going to do my y minimum at -15. that should be good enough. There you go. Try negative 20.
No, that's fun.
Okay, it keeps going. Sure, try negative 30. Ah,
Oh my
okay.
God.
You-
I did negative
I didn't want to
60.
So
correct.
what, let's think here, don't waste time. What is the question asking for?
Well, I don't know.
Zeros, right? Can I see those? Do I need to keep going?
No.
Nope.
Now, if I was asked for a minimum, would I need to keep going?
That's
Yes.
what it is.
So zeros. Remember how to do a min or max calculation? Same procedure. Second, trace, zero. Okay, and you do your left bound, so I'm actually going to go to the left side.
Oh, mine is being silly.
Enter.
0, 4.
Right side, enter. Now here you can put the cursor on the x-axis, or you can just type it in. I'm going to type -2. Fine. And there's your 0, -2, 0.
Wait, what do you put your line at? Yeah, I'm definitely.
Y max. You're still on window. I didn't change it. Zoom standard.
So, want to go up from
Yes, so to the left side is
when I do press that button to get to the
That's fine. Yep. What's your question? Okay. Yours is supposed to what? Okay, you got it? Here's your work. If you don't, I'm gonna come help you. Yes, you have to do it twice.
So, I cannot put
All right, so if you're good, you can get working. If not, I'm gonna come help you. Keep pressing one. It's not where you want Okay, anybody else?
Okay, that's that noise.
There are two of them.
I just want to make sure that, like, you have
This has the two routes.
So when I found it, like,
Yes, it's one of them. Make sure you do both. Here and then there.
I can either go quadrant, not what it's all about.
That's pretty good.
I didn't know you could do that.
There's not two squared. You can't see the